Now let's talk about arc length and how to find it. So let's say if we have a circle and we only want to find a portion of the arc length of the circle. Let's say this portion. The length of that segment in green is known as S, which is the arc length. And it's based on the angle theta. Let's say C is the center of the circle and this is A and B. The distance between points A and B around that around the edge of the circle is S. S is the arc length. The distance between C and B is the radius, which is the same as from C and A. So the arc length S is equal to the angle in radians times the radius. So for example, let's say if we have an angle of 5 radians and a radius of 12 feet, what is the arc length? So imagine a picture where R is 12 feet and the angle is 5 radians. So this is about 5 radians. Keep in mind 6.28 radians is a full circle. 3.14 radians is half a circle. So 5 radians is more than half a circle. So we want to find the distance between these 2 points around this portion of the circle. That's what we're looking for. So S is equal to theta times R. The angle is 5 radians, and the radius is 12 feet, but I like to think of it as 12 feet per radian. When I think of the word radius, I think of the length per radian. And notice that the unit radians cancel. So 5 times 12 is 60. So the arc length is 60 feet. That's how long it is. Let's try another example. So let's say if the radius is 8 centimeters and the angle theta is given to you in degrees. Let's say it's 150 degrees. What is the arc length? So if you want to draw a picture, this angle is about 150 degrees. So this is 8, that's 8. And we're looking for this distance here. And here's the angle. So go ahead and calculate S. Now what we need to do is convert theta from degrees to radians. To do that, let's multiply it by pi divided by 180. So we can cancel a 0, and so we have 15 over 18. 15 is 5 times 3. 18 is 6 times 3, so this equates to 5 pi divided by 6. Now to find the arc length, it's theta times r. So it's the angle in radians, 5 pi over 6, times the radius of 8 centimeters per radian. So this is going to be 40 pi divided by 6, which we can reduce it to 20 pi over 3. So this is the answer. That's the arc length. Now if you want to get the decimal value of it, this is going to be about 20.944 centimeters. Now if you don't want to use this equation, there's another equation that you could use if you want to keep your angle in degrees. So the arc length is equal to the angle in degrees divided by 360 times 2 pi r, where 2 pi r is the circumference of the circle. So if you think about it, let's say if we have a circle, the circumference is 2 pi r. A full circle has an angle 360. So if you plug in 360 degrees, it will be 360 over 360, which is 1 times 2 pi r, and the arc length will simply be 2 pi r. Now let's say if you have a fraction of a circle, like half a circle, the angle is 180 degrees. So it's going to be 180 over 360 times 2 pi r. So it's basically 1/2 of the entire circle. So the circumference of a semicircle is pi r. So as you can see, you can think of the arc length as being the circumference times a fraction of a circle. And that's what theta over 360 is. It's a fraction of the circle. So if the angle is 90, that means what we have is 1/4 of a circle. So this is an angle of 90 degrees. As you can see, the arc length is going to be 1/4 of the circumference, or 1/4 of 2 pi r. But now let's go ahead and finish this problem. So this is going to be 150 degrees divided by 360 degrees times 2 pi times the radius, which is 8. So we can cancel a 0. I would start with that. Now 15, I'm going to write it as 5 times 3. 36 is 3 times 12, but 12, I'm going to break that into 4 times 3. And 8, I want to write that as 4 times 2, just to do some canceling. So I can cancel a 3, and I can cancel a 4, and that's about it. So now let's multiply. So 5 times 2 is 10, times 2 is 20. So I have 20 pi, and on the bottom, a 3 in it. Now, pi is about 3.14159. If I multiply that by 20 and divide it by 3, I'm going to get the same answer, 20.944. And that's the arc length in centimeters. So there's two equations you need for arc length. S equals theta r. And only use that if theta is in radians. Now you can also use this equation, theta divided by 360 times 2 pi r, where theta is in degrees. So those are the two formulas that will help you to calculate the arc length of a circle. Now for those of you who want access to my complete online trigonometry course, here's where you can find it. Go to udemy.com, and then in the search box you could just search for trigonometry. And you can see my course is basically the one with the black background. And then here is it. I'm still adding more lectures, but here's what I have so far. Introduction into angles, drawn angles, converting degrees into radians, linear speed, angular speed problems, arc length, information on the unit circle, how to evaluate trigonometric functions using the unit circle, right triangle trigonometry, things like SOHCAHTOA. Even you can have video quizzes as well, solving word problems like angle of elevation problems. And then you have the next section, graphing sine, cosine functions, secant, tangent, inverse trig functions. Pretty much all the common stuff that you'll see in a typical trigonometry course, even solving barons, verifying trigonometric identities, summing difference formulas, double angle, half angle, and some other things too. And as I mentioned before, I'm going to add some other things as well. So feel free to check it out when you get a chance. And let's continue back to the video. Let's say if we have a circle and we want to find the area of a fraction of that circle. Let's say this is 90 degrees. And we're given a radius of 10 centimeters. What is the area of the shaded region? How can we find the area of that sector of the circle? Well, you need to use this equation, 1/2 theta r squared. But this equation only works if theta is in radians. Now, if you multiply that equation by 2 pi divided by 360, this will convert the angle from radians to degrees. So notice that the 2's will cancel. And so the area is going to be theta over 360 times pi r squared. So now theta is the angle in degrees. And if you think about it, pi r squared is the area of the entire circle. And theta over 360 is the fractional part, which represents the area of the sector relative to the entire area of the circle. So in our example, the angle is 90. And the radius is 10. So pi r squared, the area of the entire circle, is 100 pi. 90 out of 360 is basically 1/4. So to find the area of that sector, it's 1/4 of the area of the entire circle. So 1/4 of 100 pi is 25 pi. And that's how this equation works. It's simply the fractional part of the entire circle. So theta over 360 is just the fraction of the circle that represents that small sector times the area of the entire circle. So make sure you're aware of these two equations. 1/2 theta r squared, that's for the angle if it's in radians, and theta divided by 360 times pi r squared if you have the angle in degrees. Now, if you recall, going back to arc length, we said that the arc length is equal to theta times r, where theta is in radians. Now, to get the other equation, you can multiply it by 2 pi divided by 360. And if you rearrange a few things, this is equal to theta over 360 times 2 pi r. So notice how this equation is similar to this one. The area of a sector of a circle is theta over 360, that's the fractional part, times the area of the entire circle, pi r squared. The arc length is the fractional part of the circle, which is theta over 360, times the circumference, 2 pi r. And you can get it by multiplying the original equation by 2 pi over 360. The same way in which we got this equation from this one, where a was equal to 1/2 theta r squared, where theta was in radians. All we need to do is multiply it by 2 pi over 360, and we can get this equation. So I wanted to highlight the similarities between these two processes. Now, let's say if we have a circle and we want to find the area of this sector. Let's say the angle is 60 degrees and the radius is 5 feet. Go ahead and find the area of the shaded region. So because the angle is in degrees, let's use this equation, theta divided by 360 times pi r squared. So it's 60 over 360 times pi. I put equals for some reason, but that should be a multiplication symbol. So times pi times 5 squared. So we can cancel a 0. 6 divided by 36 reduces to 1 over 6. And 5 squared is 25. So the answer is 25 pi divided by 6. And if you want a decimal value for that, multiply 25 over 6 by 3.14159. And you should get about 13.1 square feet, because we're dealing with area. Area has the units, square units, in this case square feet. Let's try another example. So let's say the angle is 2 radians. And the radius is 8 centimeters. That's the distance between these 2 points. Calculate the area of the shaded region. Find the area of that sector. So in this case, we want to use this equation. Area is equal to 1/2 theta r squared, because the angle is in radians. So the angle is 2 radians, and r is 8 centimeters. So 1/2 times 2 is 1, and 8 squared is 64. So the area is 64 square centimeters.